So A is parallel to B. Then Spencer said 3 and 4 are vertical angles, so they have to be congruent. And then 1 and 4 corresponding, and the postulate says that they have to be congruent also. So if 3 is congruent to 4, and 4 is congruent to 1, what do we know about 3 and 1? What would be your reasoning? Sure. If 3 is congruent to 4, can't we take 3 and substitute it in for 4 down there? And then we'd have angle 1 congruent to angle 3. Yes? Okay. So, Megan, what kind of angles were 1 and 3 again? Yeah. Right, so if we look back at the beginning of the proof, if the lines are parallel and cut by a transversal, then alternate interior angles are what? Congruent. Always. Alternate interior angles will always be congruent when the lines are parallel. So there's your first theorem about parallel lines. If two lines are cut by a transversal and they're parallel, then alternate interior angles are congruent. Okay, to the next proof. Given A is parallel to B, we're supposed to prove that angle 1 is congruent to angle 4. What's your first step in a proof? Okay, you already have it written down. Okay, after you write the given, get into the habit of marking the picture. I know, I'm sorry, the triangles are already there, but at least you can color them in. This time we're trying to prove something about 1 and 4. So we'll look at 1 and 4. They are alternate exterior angles. Do we know anything about alternate exterior angles yet? No. Shoot. Okay, start with just one at a time then. Trevor? 2 and 4 are vertical, which would make them what? Congruent, okay. Vertical angles theorem. So this is good because we have 4 in the proof, and we're trying to prove something about angle 4. Trying to prove something about angle 1. Spence? And what do we know about corresponding angles? That they're congruent. Yeah, angle 1 corresponds with angle 2, so they have to be congruent. Angle 1 congruent to angle 2. Reason: if lines are parallel, corresponding angles are congruent. So if angle 4 is congruent to angle 2, and angle 2 is congruent to angle 1, what does that say about 1 and 4? That they're congruent. You could use substitution. You can also be using that transitive property, because if I rewrite statements 2 and 3 as if angle 4 is congruent to angle 2, and angle 2 is congruent to angle 4, then, since they, oops, that's supposed to be a 1. Since they both are congruent to angle 2, we can eliminate that middleman, and we're using 4 congruent to 1. So you can use transitive or substitution, whatever makes more sense to you in that case. Too much writing? Well, you don't have to write this part in blue. You just have to write trans. Okay, so let's go back and think about this. Given, I have 2 parallel lines cut by a transversal. Angle 1 and 4 were what type of angles again? Alternate exterior, and what did we prove about them? Good, there's the second theorem about parallel lines. If 2 parallel lines are cut by a transversal, then alternate exterior angles will always be congruent. So we have a postulate that says corresponding angles are congruent. Then we just proved 2 theorems, that alternate interior angles are congruent and alternate exterior angles are congruent. They're only congruent when the two lines are parallel. Okay, so if I gave you like these two lines, and angle 1 would correspond with angle 2, not going to be congruent because the two lines are not parallel. They have to be parallel for corresponding angles to be congruent, or alternate interior angles or alternate exterior angles. It wouldn't matter. Okay? All right. Flip it over if you haven't already. Next theorem. A is parallel to B. We want to prove that angle 3 is supplementary to angle 4, or angle 2, excuse me. That's your first step in a proof. Given. That's that freebie point. Parallel, color in the triangles. Okay, this time we're trying to prove that 3 and 2 are supplementary. So you're going to have to look at your picture and see what you can do. See what you know. Alyssa. Why does angle 1 plus angle 2 equal 180? Good. What would you put for your reasoning? Careful. Good. Angle addition postulate. You agree with her, Gracie, that the measurement of angle 1 plus the measurement of angle 2 would have to add up to 180? Because they make a nice line. Okay, and then we're going to use our angle addition postulate there. Awesome. Good, because I've got 2 in my proof, but I'm trying to prove something about angle 3, and I don't have anything listed in my statements yet. You guys know anything about angle 3? It's congruent to angle 1. 4K. Good. Because angle 3 corresponds with angle 1, so they have to be congruent. And my lines are parallel, so definitely. Angle 1, congruent to angle 3. If lines are parallel, corresponding angles are congruent. Well, we're trying to prove that 3 and 2 are supplementary. I guess we probably should have thought about what it means to be supplementary. What does that mean? They got to add up to 180. So I'm trying to get it to say that 3 plus 2 equals 180, and right now I have 1 plus 2 equals 180. What should I substitute? Substitute 3 in for 1, right? Good, because 3 and 1 are congruent. That means they have the same measure. So we can say the measure of angle 3 plus the measure of angle 2 equals 180 then. Are we done yet? No, I mean, are we done with this proof yet? We are? No, we're not. Are we? Why not? I haven't gotten to my complete final statement yet, because remember, your first step is what's behind the word given. The last step should always be verbatim, what this thing says. Well, if 3 plus 2 equals 180, are they supplementary? Okay, so we're going to say number 5 is sup to angle 2. And that's going to be by the definition of supplementary angles. 2 angles that add up to 180. We call them supplementary. Micah, I don't know. Maybe there'll be 2 steps. Maybe there'll be 5 steps. Maybe there'll be 7. I don't know. No. Around 4, but you can prove things differently. So sometimes someone might prove it in 3, where someone else proves it in 5 steps. True. All right. So looking at this proof, we have 2 parallel lines, A and B, cut by a transversal. And we just proved that 3 and 2 are supplementary. What kind of angles are 3 and 2? same side interior. So you guys just proved your third theorem about parallel lines. That if the lines are parallel, same side interior angles are always supplementary. So alternate exterior congruent, alternate interior congruent, corresponding congruent. That's not a theorem, that's a postulate. And now our same side interior angles are supplementary. Try the next one on your own. I'm going to walk around. See what you can do. So given A is parallel to B, since you all used 1, 2, and 3 mostly, I want to prove it differently than what you have on your paper, because I just walked around and told you were good. I'm going to confuse you now? I hope not. Since we're trying to prove something about 1 and 3, then we're going to look at those angles. Let's start with angle 1. Can you connect it to 2, 3, or 4? Okay, we all know it corresponds with 2. What else could you say? What about 4? Why? Spencer? Yeah, good. 1 would be congruent to 4 because they're alternate exterior angles. So we could say angle 1 is congruent to angle 4 if lines are parallel, alternate exterior angles are congruent. Okay? Now I need to prove something about 3. Since I'm using angle 4, try and connect 4 to 3. Can you connect 4 and 3 together? Why? Or what's your reason? Good, angle addition postulate. Angle addition postulate. Sweet, where should we go from there? Substitute 1 in for 4, good. Measure of angle 3 plus the measure of angle 1 equals 180. And if two angles add up to 180, we say they are what kind of angles? Supplementary, right? Angle 3 and angle 1 are supplementary. And that would be by the definition of supplementary angles. Okay? A different way to prove something that I think all 14 of you proved using 1, 2, and 3. Okay? You could have used 4 and 2 also. You could have said these guys were vertical and the corresponding. That would have just been a longer proof. But that's fine. Point being, there's more than one way to prove things. You just have to make sure that each step you have has a valuable reason. Viable. Which word is it? Viable reason for each step, okay? All right.